want me to go through every one of them, or I just go through one and then you do the rest? Frankly speaking, I don't have time to go through all of them. Which one do you prefer me to go through? Hello? Hard question. Yeah, correct. The 1B3, 1B3. 3 means the message number 3, right? The empty number 3, right? Empty number 3 is not actually hard. It's just that you need to apply trigonometry identity to convert the product of two cosine wave into the sum of two cosine wave. Then that will be easy already. Okay. Yeah. So can I have some response from the class? And the magnitude. Okay lah. Let me show you how to actually do it. Do the first one first. Yeah. So I think yeah, you need to show the magnitude. All right. Let me show you the first one first, because I don't really know. Some of you try, some of you never try, and some of you too shy to say anything. So I think I better. Okay, I show you the first one, and then you try the rest. Okay, because once you get the first one right, the rest actually is harder. I would say it's harder. I won't say the rest are easier, but it's actually, once you know the first one, then you know how to go about it. Okay, can see my screen?
Can, miss.
Okay. You see my OneNote screen as well as my PDF screen, right?
Yes.
Yeah. Okay. Let me adjust a bit. Okay. So for question 1. Okay, for question 1. Okay, question 1. My message is cosine of okay, I don't want to use bracket. To use bracket, it looks like 1. Okay, cosine of 1000 t. All right, cosine of 1000 t. So you need to, for A, you need to sketch the spectrum of NT. All right, to sketch spectrum of NT. So there are two ways to go about it. If you are not able to make use of the appendix, okay, how to make use of the appendix? Let me show you. All right, so if you refer to Appendix B basically gives you the Fourier transform of a cosine wave or even any other signal. All right, so there are two versions. One is the linear frequency f. All right, the other one is the angular frequency omega. Okay, so before you actually draw, you might want to decide first. Do you actually want to do you want to draw it in f, or do you want to draw it in omega? All right. So let's look at your equation. Yeah, this equation is cosine of 1000 t. All right. So this is actually equals to, if I were to convert it into omega form, this is omega t. All right. Cosine is always cosine of an angle. All right. So omega t will give you an angle. Yeah. So what this means is our omega is actually 1000. Yeah. And then to convert omega to f. Omega basically is equal to 2 pi f, isn't it? Yeah, 2 pi f. So that means if you want to convert to f, then you need to take omega and then you divide it by 2 pi. Yeah. So in this case, then you need to convert 1000 convert by taking 1000 and you divide it by 2 pi, right? Yeah. So if you want to draw it in sketch a spectrum in F, then you have to convert your omega to F, all right, which is 1000 over 2 pi. 1000 over 2 pi, if you press over calculator, the number is quite funny. It comes with the decimal point, all right? Well, you can also write that it's 500 over pi, no harm. Yeah. Another way is to actually draw your spectrum in omega. All right, in omega here. So if you were to draw in omega, all right, then that means your magnitude will be pi. Yeah. If you were to draw in F, your magnitude will be half of whatever the magnitude of the original frequency, the cosine signal is. So in this case, it's 1. All right. So it's half if you plot it in F. But if you plot it in omega, then you have to multiply by pi. So this is pi here. Yeah. So you have a choice between these two. So I would suggest, because the equation is in omega form, 1000 here. So I would suggest that you actually draw it in omega. All right. So to draw in omega, if you are able to make use of this table, you can see that you have two delta functions. All right. One at delta minus omega, delta of one at omega naught, the other one at minus omega naught. All right. Again, as I mentioned before, delta function gives you a magnitude of 1 when the term in the bracket is 0. All right. So as far as this expression is concerned, this term inside the bracket is 0 when omega is equals to omega naught. Yeah. And for this term is 0 when your omega is equal to minus omega naught. All right. So for any cosine signal in the time domain, all right, cosine signal in the time domain, you are going to have two impulses at the frequency domain. All right. So this is the value for F, and this is the value for omega. All right. So you can do it this way. If you don't know how to use your Fourier transform table, then what you do is maybe you want to in this case, no, for MT, no. You definitely have to use this one. So I don't expect you to do to work out the Fourier transform using equation. Just make use of this table will do. All right. So let's do a quick plot on the spectrum. So for MT, all right, the Fourier transform, I call it M omega, right? So I'm going to convert into M omega. So if I were to draw it, all right, this is M omega. So I'm going to have, this is my, okay, so if this is my omega naught. All right, this is my omega naught. Basically, this one is the omega. All right, this is the omega. In this case, if you refer back to this table, is 2 pi f naught, 2 pi f naught. I can call it omega naught, right? So that means it's at 1000. I have one at 1000. I have another one at minus 1000. All right. And what is the magnitude? Okay, because here the amplitude is 1, therefore you refer to this table is pi. Okay, and this is 0 here. So as far as the horizontal axis is concerned, this is omega. All right, omega, the unit will be in radian per second, right? Okay, so that is your M omega. Then you're asked to sketch a spectrum of double sideband suppressed carrier signal if you modulate a carrier CT equals to cosine of 10,000 T. Yeah. So Ct equals to 10,000 T. So this is A for signal number 1. So B, I have a carrier signal, Ct equals to cosine of 10,000 T. All right. So double sideband suppressed carrier signal. So that means my, did I put anything? The spectrum. Okay, I write ST, which is the double sideband suppressed carrier signal, is equals to Ct times my MT. All right. So then what you're going to have is you're going to have cosine of 10,000 T multiply with the cosine of 1,000 T. All right. And again, if you make use of your trigo identity, which is down here. All right, this one here. All right, I have two cosine, right? Cos x, cos y. So this is my x, this is my y. Yeah. So if I have two cos x, cos y, then the is actually equivalent to cos x minus y plus cos x plus y. Yeah. So again, this is 2. I don't have a 2 here. So that means on this side, it's half. Right? So half of cosine. Now, this minus this, 10,000 minus 1,000, I get 9,000 T. All right. And then this will plus cosine of x plus y. So there will be 11,000 T. Okay. So you can see that the double sideband, so this is your double sideband suppressed carrier signal. Yeah, this is in time domain. So again, what is going to look like in frequency domain? Now, instead of having one cosine wave, I have now got two cosine. I got two cosine signal. All right. So again, if you look at the top here, with one cosine as term, I have two impulses. So now with two cosine terms, I'm expecting to have four impulses. All right. Again, the impulses will be at plus minus 9,000 and plus minus 11,000. Right or not? Hello? Are you following? Or am I too fast here? Okay, let me go back. Let me go back. What is m omega? Let me write m omega down. M omega is pi of delta function omega minus 1,000 plus delta of omega plus 1,000. Yeah. So that's how I end up with this term will be 0 when omega is 1,000. So I have this one here. So this one translate into this one. And here for the second delta function, the terms in the bracket is 0 when omega is minus 1,000. Right. So this one give me this impulse at minus 1,000. Yeah. Magnitude is pi. So therefore, the magnitude of the two impulses are both pi. Okay. Okay. Can don't keep quiet leh. I don't know whether you're following or not. Is there anywhere else that you want me to go into details, or this is too easy for you? Hey, keep quiet on. Yeah, no problem. Good. Thank you. Then let's draw the next one. Where am I? Tutorial 2. Yeah, this is tutorial 2. So now, if I were to convert convert this one into its Fourier transform. That means again I'm going to use omega. All right, that will be so make use of the appendix. Okay, it will be again multiplied by a factor of pi. So because this is half, so what I have is pi over 2. All right, so now this cosine is going to give me two delta function, one at omega minus 9,000. The other one is at omega plus 9,000. Okay, that's for this cosine. The second cosine is going to give me another two delta function, which is delta omega minus 11,000 plus delta omega plus 11,000. Okay, so on your spectrum, you just need to draw. What did the question ask? Let me go back. Yeah, okay. Then your spectrum will be like okay, again, this is omega in radian per second, and this is my S omega. Right, so I have plus minus 9,000. So I write 9K. Right, this is minus 9K. And I have 11K. Right, yeah, 11K. And I also have minus 11K. Right? So what are their magnitude? What are their magnitude? The magnitude will be pi over 2, isn't it? So I have one impulse here. I have another one here. I have one here. I also have one here. Right? All right. And you can see that the carrier frequency is actually at 10K here. This is 10K. Right? So there is no carrier component there is nothing here. Yeah, from our equation, there is no impulse at 10K. So therefore the carrier has been suppressed. Yeah, as far as this signal is concerned. And then the amplitude is pi over 2, which is this one here. All right. So that is for the B. And for C asks you to label the upper sideband and lower sideband. All right, label the upper sideband and lower sideband. As I mentioned in lecture, the easiest way to recognize whether it's upper sideband or lower sideband is by referring to your carrier frequency. Your carrier frequency is here. All right. So anything lower than your carrier frequency will be your lower sideband. All right, anything higher than your carrier frequency will be your upper sideband. Okay, and same thing on this side. Okay, so this will be minus 9 is actually same as the signal at plus 9. So again, this is lower sideband and this is your upper sideband. Yep. 10. Okay, let me see your response. No response. No response. I really don't know whether you are following or not. Anybody not follow, you need help, you better say. Okay, so let's move on to the next question. Not next question. Next message signal. Okay, oops, where am I? Oops, where have I done? What have I done here? Let me see now. Oops. Let me open again. The next message signal will be, hold on, let me open up. Tutorial 2. Okay, let me share again. Okay, so for tutorial 2, message signal or baseband signal number 2, all right, is a sum of two cosine wave, right? So again, you do the same thing. You do the same thing as for individual sine wave or for individual cosine wave. All right. So this one, as far as the baseband spectrum is concerned, is going to give you 2 impulses, right? And this one is going to give you another 2 impulses, right? Actually, this is very similar to this. First cosine is very similar to the first baseband signal, except that the magnitude now is 2. All right, magnitude now is 2. So so your spectrum is going to look exactly like this, but now instead of pi, it becomes 2 pi. Yeah. And then for your second cosine wave, right, the baseband signal we have at omega at 2000. Yeah, the second omega is at 2000. So therefore, you will have another one at 2000. Can I write over here? Or do you want to copy this one first before I write over here? Hello? Do you need to copy or you already screenshot? Can someone reply me?
Yes, Miss, copy already.
All copy, All right, and so what you're going to have is for second signal, all right, at 1000, what you have is the magnitude at 1000 will be 2, all right, and then for 2000, you're going to have, this is at 2000, too long. You're going to have another one, 2000. Okay, this is at 2K, this is at minus 2K, and the amplitude of this one will be pi. All right, why pi? Because here the amplitude is 1. Yeah. And okay, now baseband, you have 4 impulses. That means when you modulate the carrier, you're going to have 8. You're going to 8 of this. All right, so same thing. You go through the equation, work it out. All right, work out the delta function if you need. And then you're going to get all the impulses that you need at the respective frequencies. Yeah. So again, from what I can see is now, if you were to modify, because that is 2, that means this will be pi, right? Then you have 10,000 minus 2,000, so that will give you something at 8K, and that will give you another thing at 12K. All right, meaning on the other side at minus 8K, you're going to have an impulse. At minus 12K, you're going to have another impulse. All right. And then because the cos 2000, the magnitude is half of this. So that means you expect it to be half as well. To be half. So when this is pi, that means this is pi over 2. This is pi over 2. Yeah, correct. Because we have 2 here. This one is 2. So we end up pi. Then this is 1. So that will be pi over 2 for the 8K and 12K. Okay, so this is for the second second MT, second ST. Okay, you go and try out. Okay, you try out yourself, and you should be able to get this. And then for the third one, all right, the third one, as I mentioned before, what you need to do is to convert. All right, this is cost 1,000. Your MT is cost 1,000 T and cost 3,000 T. So you need to first use trigger of 1,000. Okay, meaning you're going to multiply two cosine signal together. So what you need to do is use trigger, convert it to two cosine terms. So you're going to have cos 3,000. 1,000 minus 3,000 is minus 2,000. So for cosine signal, remember cosine, I talked about cosine being an even function. All right, even function. That means cosine of minus 2,000 is the same as cosine 2,000. All right, so they give you cosine 2,000 T plus cosine 3,000 plus 1,000 will give you 4,000 T. All right, so that will be your MT. All right, so that means your baseband signal again consists of two cosine components, one at omega 2000, another one at omega 4000, both of magnitude half. All right, so from here you draw you get your spectrum. So that means your M omega. All right, so this is half. Half mean that will be pi over 2. All right, and that will be, again, you're going to have 2 delta for each cosine wave. So that will be minus 2,000 plus omega plus 2,000. This is from here. Then the other one is give you another 2, which is omega minus 4,000 plus delta omega plus 4,000. Right? So here again, you are going to have 4 impulses. Right? At this is at plus 2,000 minus 2,000 plus 4,000 minus 4,000, all magnitude pi over 2. Right? You can sketch it, right? Can or not? I hope you can. You try out like the same as the previous one again. So you sketch all these 4 pulses. And then the modulated signal, double sideband suppressed carrier signal, will be similar to this one here. Right? Because we have 2 cosine term in our baseband signal. Right? 2 cosine term in our baseband signal will give you 8 impulses. Right? 2 cosine term in baseband signal will give you 4 cosine expression. Right? 4 cosine expression will give you 8 impulses. Can? You're all very quiet. I don't know what's happening. Let me see what's happening to you. If you cannot, then you better say, So the highest frequency is USB. Again, you need to refer. You need to refer to your carrier component. All right, now, okay, let's look at this one again. The second one. So where is your USB? All right, your USB, your USB is on the right hand side of your carrier component. So now if you have 2 impulses on the right hand side of your carrier frequency, then that means these 2 are your USB. All right, and for LSB, this one is also LSB. So these 2 are LSB. All right, always make reference to your carrier frequency. Yeah. So same thing here. This is your LFP as well. And this one is your USB. All right, as I mentioned before, negative frequency doesn't mean that the value is smaller because it's more negative. It just only the direction is opposite, that's all. So only consider the magnitude. Okay. Any other questions? You really need to work it out yourself, yeah? So with more practice, this will be very easy. You don't wait until last minute only you want to practice. Then you confuse already. Hello? Say something. Okay, thank you, Soche. What about the rest? If you cannot follow, then you better say something, because this is still something very easy. If you cannot follow, then you have problem later on. Okay, and let me stop sharing. Okay, if you are too shy to ask me now in front of your class, then maybe you want to ask me at a different time. It's fine with me. Right, just let me know. Okay, so I think this should be enough for today. Yeah. We meet again later.